Secondary storage technology. Electronic commerce and electronic business and regulations such as Sarbanes-Oxley have made storage a strategic technology. The amount of data that companies now need to store is doubling every 12 to 18 months. The principal storage technologies are magnetic disks, optical disk, magnetic tape, and storage networks. Magnetic disks. The most widely used secondary storage medium today is the magnetic disk. PCs have hard drives, and large mainframes and mid-range computer systems have multiple hard disk drives because they require immense disk storage capacity in the gigabyte and terabyte range. Earlier generation PCs used floppy disks for storage, but they have been largely supplanted by USB flash drivers, also known as USB drives. The USB flash drive provides portable flash memory storage by plugging into a computer's USB port. It can provide up to 256 gigabytes of portable storage capacity and is small enough to fit into a pocket. Servers and computers with large storage requirements use a disk technology called RAID, Redundant Array of Inexpensive Disks. RAID devices package more than 100 disk drives, a controller chip, and a specialized software into a single large unit delivering data over multiple paths of simultaneously. Figure 4.3. Optical disks. Three disks use laser technology to store large quantities of data, including sound and images, in a highly compact form. They are available for both PCs and large computers. CD-ROM, compact disk read-only memory for PCs, is a 4.7-inch compact disk that can store up to 660 gigabytes. CD-ROM is read-only storage, but CD-RW, CD rewritable disks, are rewritable. Digital video disks, DVDs, are optical disks, the same size as CD-ROMs, but of even higher capacity, storing a minimum of 4.7 gigabytes of data. DVDs are now the favored technology for storing video and large quantities of text, graphics, and audio data, and rewritable DVD-RW disks are widely used in personal computer systems. Magnetic tape. Some companies still use magnetic tape, an older storage technology that is used for secondary storage for large quantities of data that are needed rapidly but not instantly. It stores data sequentially, as is relatively slow compared to the speed of other secondary storage media. Storage networking. Large firms are turning to network-based storage technologies to deal with the complexity and cost of mushrooming storage requirements. Storage area networks, SAN, connect multiple storage devices on a separate high-speed network dedicated to storage. The SAN creates a large central pool of storage that can be rapidly accessed and shared by multiple servers, input and output devices. Human beings interact with computer systems largely through input and output devices. Input devices gather data and convert them into electronic form for use by the computer, whereas output devices display data after they have been processed. Table 4.1 describes the principal input and output devices. Contemporary hardware trends. The exploding power of computer hardware and networking technology has dramatically changed how business organize their computing power, putting more of this power on networks and mobile handheld devices. Let's look at the 7 hardware trends. The emerging mobile digital platform, nanotechnology, virtualization, cloud computing, green computing, high-performance power-saving processors, and autonomic computing. The emerging mobile digital platform. Chapter 1 pointed out that new mobile digital computing platforms have emerged as alternatives to PCs and large computers. Cell phones and smartphones such as BlackBerry and iPhone have taken on many functions of handheld computers, including BlackBerry and iPhone, including transmission of data, surfing the web, transmitting emails and instant messages, displaying digital content, and exchanging data with internal corporate systems. The new mobile platform also includes small, low-cost, lightweight sub-notebooks called netbooks optimized for wireless communication and internet access, tablet computers such as the iPad, and digital e-book readers such as Amazon's Kindle with some web access capabilities. In a few years, smartphones and tablet computers will be the primary means of accessing the internet, with business computing moving increasingly from PCs and desktop machines to these mobile devices. For example, senior executives at General Motors are using smartphone applications that drill down into vehicle sales information, financial performance, manufacturing metrics, and project management status. Nanotechnology. Over the years, microprocessor manufacturers have been able to exponentially increase processing power while shrinking chip size by finding ways to pack more transistors into less space. They are now turning to nanotechnology to shrink the size of transistors down to the width of several atoms. Nanotechnology uses individual atoms and molecules to create computer chips and other devices that are thousands of times smaller than current technologies permit. IBM and other research labs have created transistors from nanotubes and other electrical devices and have developed a manufacturing process for producing nanotube processors economically. Figure 4.5. Virtualization is the process of presenting a set of computing resources such as computing power or data storage so that they can be all accessed in ways that are not restricted by physical configuration or geographical location. Virtualization enables a single physical resource, such as a server or a storage device, to appear to the user as multiple logical resources. For example, a server or mainframe can be configured to run many instances of an operating system so that it acts like many different machines. Virtualization also enables multiple physical resources, such as storage devices or servers, to appear as a single logical resource, as would be the case for storage area networks or grid computing. Virtualization makes it possible for a company to handle its computer processing and storage using computing resources housed in remote locations. VMware is the leading virtualization software vendor for the Windows and Linux servers. Microsoft offers its own virtual server product and has built virtualization capabilities into the newest version of Windows Server. By providing the ability to host multiple systems on a single physical machine, virtualization helps organizations increase equipment utilization rates, conserving data center space and energy usage. Most servers run at just 15 to 20% of capacity, and virtualization can boost server utilization rates to 70% or higher. Higher utilization rates translate into fewer computers required to process the same amount of work, as illustrated by Bart's experience with virtualization in the chapter opening case. Virtualization also facilitates centralization and consolidation of the hardware administration. It is now possible for companies and individuals to perform all of their computing work using a virtualized IT infrastructure, as is the case with cloud computing. Cloud computing. Cloud computing is a model of computing in which the computer processing, storage, software, and other services are provided as a pool of virtualized services over a network, primarily the Internet. These clouds of computing resources can be accessed on an as-needed basis for any connected device and location. Figure 4.6 illustrates the cloud computing concept. The U.S. National Institute of Standards and Technology, NIST, defines cloud computing in having the following essential characteristics. Mel and Grants, 2009. On-demand self-service. Consumers can obtain computing capabilities such as server time or network storage as needed automatically on their own. Ubiquitous network access. Cloud resources can be accessed using standard network and internet devices, including mobile platforms. Location-independent resource pooling. Computing resources are pooled to serve multiple users with different virtual resources dynamically assigned according to user demand. The user generally does not know where the computing resources are located. Rapid elasticity. Computing resources can be rapidly provisioned increased or decreased to meet changing user demand. Measured service. Charges for cloud resources are based on the amounts of resources actually used. Cloud computing consists of 3 different types of services. Cloud infrastructure as a service. Consumers use processing, storage, networking, and other computing resources from cloud service providers to run their information systems. For example, Amazon uses the spare capacity of its IT infrastructure to provide a broadly based cloud environment selling IT infrastructure services. These include its simple storage service, S3, for storing customers' data, and its Elastic Compute Cloud, EC2, service for running their applications. Users pay only for the amount of computing and storage capacity they actually use. See the chapter ending case study. Cloud platform as a service. Customers use infrastructure and programming tools supported by the cloud service provider to develop their own applications. For example, IBM offers a smart business application development and test service for software development and testing on the IBM cloud. Another example of Salesforce.com's Force.com, which allows developers to build applications that are hosted on its servers as a service. Cloud software as a service. Customers use software hosted by the vendor on the vendor's cloud infrastructure and delivered over a network. Leading examples are Google Apps, which provides common business applications online, and Salesforce.com, which also leases customer relationship management and the related software services over the internet. Both charge users an annual subscription fee, although Google App also has a pared-down free version. Users access these applications from a web browser, and the data and software are maintained on the provider's remote servers. A cloud can be private or public. A public cloud is owned and maintained by a cloud server provider such as Amazon Web Services and made available to the general public or industry group. A private cloud is operated solely by an organization. It may be managed by the organization or a third party. It may exist on or off-premise. Like public clouds, private clouds are able to allocate storage, computing power, or other resources seamlessly to provide computing resources on an as-needed basis. Companies that want flexible IT resources in a cloud service model while retaining control over their own IT infrastructure are gravitating towards these private clouds. See the chapter ending case study. Since organizations using public clouds do not own the infrastructure, they do not have to make large investments in their own hardware and software. Instead, they purchase their computing services from remote providers and pay only for the amount of computing power they actually use, utility computing, or are billed on a monthly or annual subscription basis. The term on-demand computing has also been used to describe such services. Cloud computing has some drawbacks. Unless users make provisions for storing their data locally, the responsibility for data storage and control is in the hands of the provider. Systems to an outside vendor that also works with other companies. Companies expect their systems to be available 24/7 and do not want to suffer any loss of business capability if cloud infrastructures malfunction. Nevertheless, the trend is for companies to shift more of their computer processing and storage to some form of cloud infrastructure. I lost myself. Cloud computer has some drawbacks. Unless users make provisions for storing their data locally, the responsibility for the data storage and control is in the hands of the provider. Some companies worry about the security risks related to entrusting their critical data and systems to an outside vendor that also works with other companies. Companies expect their systems to be available 24/7 and do not want to suffer any loss of business capability if cloud infrastructures malfunction. Nevertheless, the trend is for companies to shift more of their computer processing storage to some form of cloud infrastructure. You can find out more about cloud computing in the learning tracks for this chapter.